Okay, morning everyone, welcome. Today we are talking about instantaneous rates of change, and this is going to really draw out the element of calculus, about exactly what it is that we're doing in calculus. And then the skill here is not going to be overly complex at all, okay? So I'm just going to point out the difference. Yesterday we did average rates of change, didn't we? And what you should remember is average rates of change was the rate of change between 2 points. So it's the rate of change over that specific interval. So a great example of an average rate of change is when you're driving to Adelaide. Okay, if you're driving from Mount Gambier to Adelaide, you drive through places like Kiki and Canalpin, and they have average speed camera safety zone. And so the way that works is it's going to take a photo of your car at Kiki, and then it's going to take a photo of your car at Canalpin, and it's going to work out how long has it taken you to travel this distance. And so it's working out what's your average rate of change. Is it at an acceptable range? Is it below the speed limit? Okay, and so that's a really good example of average rate of change. Instantaneous rate of change, on the other hand, that's what we're looking at today, is about the rate of change at one exact moment in time. So a great example of that is, you're driving along safely and you're getting excited about the music that's playing, and so you don't notice, but you sort of accelerate a little bit more, and then there's the policeman sitting on the side of the road, hiding behind the bush, pointing his speed gun at you, and he catches you doing 140 at one instant in time. Okay, despite your average rate of change might be correct. You might be safe, over the speed camera safety zones, but he's caught you at one instant in time where you were over the speed limit. So that'd be unfortunate. So that's what we mean by instantaneous. And so if instantaneous is at an exact point in time, so we're not talking about over an interval, I'm talking about what is the rate of change at this point. And the way we're going to do that is we're going to draw a tangent to the curve at that point and find the slope of the tangent. So that's a word that maybe we've heard before, tangent function. You can think of tangent function. So a tangent is just a line that is parallel to the curve at a particular point. So it's a straight line. Parallel means it has the same slope, the same level of steepness to the curve at a particular point. So I'm going to draw a tangent here, and in the textbook the tangents are going to be drawn for you, just so that you get the same answers as the ones that are in the book, and obviously we'll do that in the test as well. But the way you would draw a tangent is you want to put your ruler there such that your ruler has the same steepness as the slope at that point, and then you draw a line there. Okay, and then the slope of this line, we can calculate the slope of this line quite easily because we can determine any number of points on it. The slope of this line is the same as the slope at that point. And so we're using the slope of the tangent to tell us how steep is it at that exact point, not over an interval, at that point exactly. So what's the question say? Well, let's answer the question. Draw tangents at time is 3. So that's pretty close to 3, okay? That's my tangent at time is 3. And I'm going to calculate the slope of this tangent. So I can select any points along. I might go with the 3. Obviously, if we've chosen an x value of 3, that's going to be one of the points. And what's the corresponding y value? About 30. All right, and then we can just go with anywhere we can see a clear point. So when we've got 20, we seem to have 6. 20 corresponds with 6. So that's going to be our next point. X is 6 and y is 20. And now we can calculate the slope of that line. Okay, the slope of that line is going to be 20 take 30 on 6 take 3. We've got minus 3.3. And the rate of change here, this is the same context we were talking about yesterday. It's grams of poison, isn't it? It's number of beetles it kills per grams of poison. So minus 3.3 beetles per gram of poison. So that's what we're doing here today. That's the difference between average and instantaneous, and we're just doing a few instantaneous calculations. And then we can cruise through that pretty quickly, I think. Let's get some time on our folio again. So it's good to do a bit of our folio now, because in weeks to come, as in next week and the week after, we're not going to have a whole lot of class time to do it. We're going to be pretty devoted to our textbook work. There's quite a bit coming up. So it's good to have a couple of small lessons, but take advantage of them. Okay? Thank you.